Now are something called even and odd functions. So first, quick definitions, and I mean quick. Even functions are symmetric about the x-axis. Ta-da! Now what that means is if you're looking at an even function, then it's going to have a graph so it's really easy graphically to tell if something's even or odd. If it looks like our friend the parabola, if you reflect this bit over the x-axis, it maps onto this. So we'd say it's symmetric about the x-axis. It's mirror image. That's it. Odd functions have 180-degree rotational symmetry about the origin. So that would mean if you, about the origin, were to take and rotate the thing 180 degrees, it should map onto itself. The simplest example would be our friend the cubic function, because if you take any point here and rotate it 180 degrees about the origin, it maps onto another point here. Now, truth be told, not a lot of functions are even, not a lot of functions are odd. Most fall into something called the neither category. Okay, now that's graphically. Formulaically, even means that f of opposite x equals f of x. In English, the y value is the same if you plug in the positive or negative value of a number with the same magnitude. In other words, f of -2 would be the same as f of 2. Now remember from function notation, f of -2 is a y value, and you get the same y value whether you plug the positive or negative in. Now if you think about that, it makes sense, because if we're talking about something being symmetric about the origin, some equal point here would have the same y value over here. Odd means that f of opposite x equals the opposite of f of x. Please note the location of the negative is important. This means you're plugging the opposite value of the x. If you plug that opposite of that x, a positive, let's say, and then the whole function is the opposite sign. Meaning, in English, if you plug in a negative value for x, then the y value will be the opposite sign had you plugged in the positive value of x. Graphically, believe it or not, that makes sense. If you're looking at our most basic so if that's a cubic model, if you were to plug in x, you'd get a, well, let's do this. Yeah. You'd get a certain y value. And if you were to plug in opposite x, right, you'd get a certain y value. How are these two y values related? Well, one would be a negative and the other would be a positive. Fair enough? Okay, so let's take a look at some concrete examples real quickly. So, is f of x equals x squared odd, even, or neither? So you need to do two things. You need to figure out what f of opposite x is, and you need to see what you get. F of opposite x means you're plugging negative x in here, which means you're taking negative x and you're squaring it. Do order of operations make a difference? You bet, a big difference. This means that f of opposite x, which is what we're getting, if you simplify that, negative times negative is equal to x squared. So, how does that compare to the original? It is the same. It is equal to f of x, which implies, therefore, if then, right, that this is even. Okay? Is f of x equals x cubed odd, even, or neither? So, in this case, we take f of opposite x. It's always going to be our beginning. Plug opposite x in. That's step one. Okay? What do we get? Negative x. Then we cube it. Is that something we can simplify? F of opposite x equals, well, negative times a negative times a negative means that the result will be just like we took x and cubed it, except it will be the opposite sign. Okay. Hopefully you can see that this is not the same as f of x. What does that mean? Well, then you need to do one more thing. If this happens, don't panic. What is opposite f of x? Well, that's if you take a negative sign in front of it. Now, this is pretty straightforward. So what I did is I took the opposite. That was my step 2, because these didn't match. This does not match f of x. So what does that mean? This does match opposite f of x. So this implies together this bad boy is odd. All right. F of x equals x squared plus 2x. Well, we follow through. We take opposite x and we plug it in. So we have opposite x squared, don't forget the parentheses are kind of important, and 2 times opposite x. What is this? F of opposite x equals, well, we know that squaring something is the same as just plain old x squared, but 2 times negative x makes it minus 2x. This does not match this, therefore it is not even. Next step, figure out what opposite f of x is, which means what? We take the opposite of the whole thing. When we say the whole thing, we mean that quantity, as in wrap that bad boy in some parentheses, which implies that we have to distribute. So then what we have to do is compare. We know that it's not even because this does not match the original. Now we take this, and we compare them, and they do not match. So therefore it is not odd, which makes it neither. Therefore, neither. That's the crash course.